Hello everyone, I am B. Prabha, working as Assistant Professor in Department of Chemistry at Katpam Academy of Higher Education. In last class, we have seen about electronic configuration of elements and periodic table. Today we see about same the concept which classifies the elements. We have classified the elements in blocks, 4 types of blocks, that is called S block, P block, D block and F block. So, we go to the topic. The topic heading is electronic configuration and classification of elements. So, here the Aufbau principle. The Aufbau principle and that electronic configuration of elements is the main two concept which gave the theoretical fundamental to classify the elements. Theoretical fundamentals to classify the elements. Okay. So, in alpha principle we in that the elements are arranged in increasing order of energy level. Increasing order of energy level. And that energy levels are written and named as electronic configuration. Okay. So, there's two principles, first one is alpha and electronic configuration. We classify the elements into 4 types, that is called block elements, that is belongs to 4 types. One is S block elements and another one is P block elements and third one is D block elements and fourth one is F block elements. So, after that we clearly see about what is S block, what is P block and what is T block and what is F block elements. Okay. Now, first we see about S block elements. Before going to S block elements, according to electronic configuration, the periodic table is classified into 18 groups. Okay. And first 2 groups are called as S block elements and group 3 to 12 is called as D block elements and the group 13 to 18 called as P block elements. Okay. Now we are going to S block elements, and what is S block elements means the elements which have outermost electron in its S orbital is known as S block elements. Example, hydrogen. Hydrogen is atomic number 1 and its electronic configuration is 1s1. And another one, that is lithium, and its atomic number is 3 and its electronic configuration is 1s2, 2s1. So, here it is 1s1 and here lithium is 2s1. Okay. And next element is sodium, which have 3s1 outermost electronic configuration, and another one potassium, which has 4s1 electronic configuration, and another one after potassium, that is rubidium, which have outermost orbital electron in 5s orbit, and another one cesium, which is 6s1, and last one, that is francium, which have last outermost electron in 7s orbital. Okay. Here in the period the numbers are increased 1, 2, 3, 4, 5, 6, 7, but orbital is same, that is S orbital, and it's in S orbital it have only one electron. Here 1s1, here 2s1, 3s1, 4s1, 5s1, 6s1 and 7s1. So, this is also called as alkali metals. Alkali metals. Why these are have called as alkali metals means it have a alkali in nature. So that's why these elements are considered as alkali metals. And in same S block elements another one group is there, that is called alkaline earth metal. Alkaline earth metals. Why it is called as alkaline earth metals means it is mostly abundant in the earth crust in an oxide form. So that's why it is called as alkaline earth metals. What are the alkaline earth metals are being here means, first one is beryllium and another one magnesium and calcium, strontium, barium, radium. These are comes under alkaline earth metals. And beryllium atomic number is 4, magnesium atomic number is 12, calcium atomic number 20. Okay, so here what is the electronic configuration means, all are in 2s2, 3s2, 4s2, 5s2, 6s2 and 7s2. Here the s orbital are completely filled in this series. Okay, so these two groups are belongs to s block elements and its outermost electronic configuration completed between 2s1 and 2s2. Okay, and next we go to p block elements. Here the p block elements, the outermost electrons are filled in p orbitals. Okay, so here the general formula is written as ns2, np12, ns2, np6. Okay, so maximum number of electrons filling in p orbital is 6. It is already we seen in the before classes. Okay, so here the p blocks group is from group 13 to group 18. Totally 6 groups are present in the p block. Okay, and the first element in the p block is boron and carbon, nitrogen, oxygen, fluorine and neon. Okay, here the helium is present above the neon, but its atomic number is 2 and its electronic configuration is 1s2. Okay, this is one of the exception in the periodic table, because helium is belongs to s block only, but here this s orbital is completely filled form, so that's why it is act like as noble gases. So for that property it is placed in the above noble gas series. Okay, so here the group 13 starts with boron. Okay, and its atomic number is 5 and its electronic configuration is 2s2, 2p1. Okay, and its in this carbon's atomic number is 6 and the electronic configuration is 2s2, 2p2, and for nitrogen 2s2, 2p3, and for oxygen 2s2, 2p4, and for fluorine 2s2, 2p5, and here it is 2s2, 2p6. Okay, here helium, neon, argon, krypton, xenon, radon and last one oganesson is there. This is the 118th element named as oganesson, and here the all electronic configurations are completely filled. Okay, the s block and p block elements are completely filled. Due to this complete filling of orbit, it is act like a noble gases, because here the chemical reactivity is low. Chemical reactivity low because it have completely filled orbits. We can't easily remove the electron or easily donate the electron in that element is very difficult. Okay, due to that difficulty the reactivity gets lower. Okay, so in p block elements another two main groups are there, the group 17th and group 16th. This group 17th elements are called as halogen series, and this group 16 elements are called as chalcogen series. Okay, these two elements are high electronegativity, and it absorbs the one electron or two electron. It attains stable noble gas configuration. Okay, so noble gas configuration is an stable configuration. Okay, so if this chalcogen absorb two electron, this halogen absorb one electron, means these two groups are have a completely filled orbit like halogen series, noble gas series. Okay, so these are the main groups present in the p block elements. In this p block elements three types of elements are there. One is halogens, and another one is noble gases. These noble gases are comes under non-metals. Okay, here this p block element we have three types of elements. One is metals, and another one is non-metals, and third one is metalloids. Metalloids also called as semi-metals. Okay, so this here the in p block elements the totally 19 non-metals are there. 19 non-metals are there. This helium, neon, argon, krypton, xenon, radon, oganesson, and here boron, carbon, nitrogen, oxygen, fluorine, here chlorine and bromine, and another one iodine. These elements are comes under non-metals, that is totally 19 elements. Okay, so for metalloids or semi-metals there is an 7 elements. Okay, 7 semi-metals are there, except that all are in metals type. Okay, so here what is the example for metal is boron, next aluminium, gallium, indium, thallium, niobium. These are it is an examples for p block metals. Okay, what is the non-metal is silicon, germanium, gallium. Okay, these are tellurium, polonium. These are comes under non-metals, metalloids type, semi-metals. What is the semi-metal means? If we heat or give a thermal energy or a photoelectrical energy, this it is these elements or act like an metals. Okay, but actually or spontaneous naturally it is an act as non-metal. So this metalloids or semi-metal have two types of property. One is metallic property and another one is non-metallic property. These have these two both properties. So it is called as metalloids or semi-metals. Okay. Next we see about d block elements. What is d block elements means? This outermost electrons are filled in the d blocks. So d block element starts from atomic number 21 and the element is scandium. Okay, so this is this general formula is written as n minus 1 d power 1 to 10 and n is 0 to 2. So what this meaning means? The d block elements is in this series the vertical lines that 3D is there, 4D, 5D and 6D, but in vertical line starts from hydrogen. So its number is n equal to 1 and n equal to 2, n equal to 3, n equal to 4. When comes to fourth vertical series, the 3D series is centrally present, and it comes to n equal to 5, fifth vertical, the 4D series is present. So that's why this general formula written as n minus 1 d power 1 to 10. What this meaning is, in D block, the minimum electron filled is 1 and maximum number of electron filled in the d orbital number is 10. That is why we written as d power 1 to 10. Okay, here this scandium starts with d power 1 and this zinc ends with d power 10. Okay, so here the scandium's electronic configuration is 4s2 and 3d1. Okay, and zinc's electronic configuration is 4s2 3d10. Okay, here it is present in between the s block and p block elements. Okay, here this s block elements is highly reactive. Due to this highly reactivity, this is not present in a pure form in the earth crust. It is mostly present in the form of oxides in their natures. Okay, so what is the reason is its higher reactivity. And already we see about in p block elements it contains metals, non-metals and metalloids. So its reactivity is comparatively low. So this D block is the connecting bridge of this highly reactive metals and less reactive metals. That is why this D block called as transition series. Transition series. Okay, and another one definition is there for transition series, because it have a vacant orbital for transfer the electrons from d orbital to s orbital or s orbital to d orbital. Due to that transition also it is called as transition elements. Okay, here the elements which are present in the d block elements called as transition elements. Okay, the elements which is in s block and p block, the combination of s block and p block elements collectively called as main group elements. Main group elements, and in d block elements which are called as transition elements. Okay, so here in d block elements two exceptions are there. Okay, one is palladium, because here the palladium's electronic configuration written as 5s2 4d8, but here the palladium have electronic configuration 4d10. They have its complete electronic configuration. In d block elements, due to this reason, this palladium have low reactivity, and likewise this zinc, cadmium and Hg, which all are have completely filled electrons. That means 3d10 4s2, 4d10 5s2, and here 5d10 6s2. So this completeness of orbitals decreases the reactivity. So here zinc, cadmium and mercury's reactivity is relatively low compared to other elements present in the d block elements. In d block elements, all elements are comes under metals. All elements are comes under metals. Here there is no metalloids, there is no semi-metals, and also in s block elements these all are belongs to metals only. The first row the first row is called as alkali metals and second row is known as alkaline earth metals. Okay, here in d block elements the collective of elements which is called as lanthanide and actinide, that lanthanide have 14 elements and this actinide series have 14 elements, that is separately placed under the periodic table. Okay. So this lanthanide starts from 57th atomic number to 71. Okay. So starting element is lanthanide and ending element is lutetium. And here that actinide series starts with actinide and ends with lawrencium. Okay. So here why these are belongs separately means this 14 elements are having an electronic filling in f orbital. So these two series are called as f block elements. Okay. So here if this 57th lanthanide series electronic configuration starts from 4f12, that lutetium's electronic configuration ends with 4f14. Okay, so the general formula of f block is n minus 2 f 1 to 14 and n minus 1 d power 0 to 2 and ns power 2. Okay, this is the general formula for f block elements. Here this is n minus 2. Why it is means here this sixth vertical series there is already 5d series, that is n minus 1 d series, and this lanthanide have orbit 4f. Okay, after 5d the next energy level is 4f according to Aufbau principles. That's why electron in lanthanide filled in 4f1 and lutetium's ends with 4f14. So f orbit's maximum electron covering capacity is 14 electron and minimum number is 1. Okay. So why it is present in the same means here this 14 elements have similar properties. Okay. So that's why these are placed in one box. Okay. And actinide, these 14 elements also have a same similar chemical and physical properties. That's why it is kept in the one box. Okay. So totally this 14 and this 14 are comes under f block elements, and one is called as lanthanide and another one is called actinides. It is present inside of the transition series. So this f block elements also called inner transition elements. This f block elements also called as inner transition elements. Okay. So in this inner transition elements, another one main criteria is that in actinide series most of the presence are radioactive. Okay. So we know about this thorium and uranium, two famous compounds which are early recognized in the earth crust in a pure form, which have a radioactive, and after this uranium all elements are called generally called as trans uranium compounds. Okay. Here the actinides are mostly radioactive elements, so these properties are practically proven. Okay, because of its radioactive nature. Okay. So these are the elements which are classified as S block elements, P block, D block and F block elements, and we clearly seen about what is S block, what is P, what is D and what is F block elements, and also known about its another names. So these are all present in this topic, and in next class we see about nomenclature of the elements which is belongs to the atomic number 100. Okay, thank you.